All right, now for the very long and tedious part of this journey. So if you've got some music in the background, if you've got some snacks with you, if you got a drink on, you know, just know that this is the most intensive part. This takes the most time, but this will save you a lot of headaches in the future. So in this one, just like what we did with the Raspberry Pi here, we need to first cut these to the appropriate numbers on the boards. And you will be using the pins that it actually comes with. So you'll be snapping these off to the right numbers, and then you will cut these in half. And what I mean by half, I mean that you'll take your cutters here and you will actually cut the long pin in half, making it equal in length to the bottom pin. Now, if you really wanted to, you could, I'll get one that's about the right size. You could also cut the bottom pins to the right height. It's not necessary. It is, however, a little bit recommended because these pins will come out the other side. But on the top side of this board, you won't have to worry about it as much, about the height. Neither for desoldering these pins or for contacting other surfaces. It's just the other side. You'll want a little bit of room just in case your 5808s happen to droop over a little bit. But if you wanted to just be certain that it won't ever contact, you can obviously put a little bit of glue. You can even put some Kapton tape on top of here. It's fine. But just know that we need to cut these to height, otherwise they're going to be too long. So what you're going to need to do is you're going to need to separate these pins according to the number of slots right here. So you will need one set of 5 pins, 2 sets of 3, so a 3 and a 3, and then you will need a 1. And the 1 pin is always going towards the D9. And that's how you can tell where you are on the board. So right here, in backwards, because it's kind of a little joke, you read it in a mirror, you actually have the FTDI side, which is the one with the 6 pins on this side. That always goes here. Now, another way you can think about it is the button, the reset button, always goes towards the center. So, and if you really want to know, we have D9 labeled inside the boxes. And D9 is the 9 pin right here. It's always in the corner, depending on the board you get. But for the Pro Minis that we're telling you to buy, it's always going to be in the corner on the pin on the right side, furthest away from the FTDI connector. So again, you need to cut a 5, 2 3s, 2 2s, and a 1. So how we recommend doing that is taking your flush cutters, and usually these 2.54 millimeter pitch brass connectors, the pins, are generally notched, and that's so that you can easily break it with your fingers. Now, in the past, a lot of us have a bit bigger fingers than normal, so we recommend using your flush cutters to cut them to the precise height. Just keep in mind though, because of how flush cutters are, and they have that little angle side on one side and flat on the other, that these could go flying. So make sure that you don't, 1, cut yourself, but 2, you hold on so that they don't fly off. So we're going to cut off the 1. So the 1 pin here. Then we're going to cut the 5. So 1, 2, 3, 4, 5. So we'll cut here. So that's the 5 pin. And then your 2 3s happen to be on the same board right here. So you can just cut this in 2. And then you can cut 2 2s off of this. Now the good part here is if you've messed up in the future, like on the other nodes, you can obviously just take these And now you can either create a 5, create some 3s, or create some 2s out of this. So take your angled part, which we won't even need this on here. It's generally only used for the FTDI connector over here. But because of the way that we've done it, we don't have to solder this on. And also this is a wasted space. Even putting the pins up here like so is a lot of wasted space. We're trying to make it as compact in all directions as possible. So that means not having to actually solder on these connectors. We only need them once, we don't need them again. So take that to the side and just put your extra pins to the side here. Now you can take all of these and move them over here. If you like to kit, and if you know what I mean by kitting, it's like when you take all of your Legos and you kind of separate them out into their appropriate sizes, and you know, you get them ready to go, because then you can just take all of your 1s and you can populate the 1s, and you can take all of your 2s and then populate all the 2s. So I'm gonna fast forward through this next part here, but for you, you can probably pause the video and kind of sit back and relax and start cutting out your pins if you want to. Alright, so by now you should have been able to cut all of these and somewhat place them on the board here. What we'll do now is, you can, if you want to, you can, of course, you know, file some of these things down if you wanted to. You can just kind of move it around. They're not going to really get in the way, but if you do notice when you start putting these on, they do. Just take and kind of move it around. This is just the fiberglass. There's no dual layer, there's no 4-layer Arduino Pro Minis out there. So all of the stuff that's on the edge is just them with their break-offs. They use V-grooves to make a lot of boards on a single panel, and what that allows them to do is just snap them off and to put them in little bags. But sometimes the suppliers don't really file these down, so you can if you want. But the next part, what we're going to do is we're going to take those pins, and like before, especially on the Raspberry Pi part, you're going to take them and you're going to snip them in half. Be careful. These tend to fly off. So not only do this in an area where there's not a lot of people that go barefoot, don't do this in a garage where you have a lot of cars, because these pins do fly into all the different spots. They might, you know, puncture a tire, even though they're very, very small. Just do this in an area that you know if these fly out, you can easily vacuum them up or pick them up later. But what you're going to do is you're going to cut the pins on the side where they are the longest. And you're going to do it in such a way that when you put it into the board here, that when it comes out the other side, it's flush. So you can cut a little bit more than half, but what we suggest is to cut about half. It gives you enough length. If you're so adventurous, you can. If you cut a little bit more, it is about the height that you want it. That would actually be flush with the board. So this is the tedious part. You will be doing the same exact thing with these round pins for the RX 5808s later on. So I'm going to fast forward through this next part. So once you're done, just follow up at the end and we'll start to do the soldering. that was pretty intense. I'm not gonna lie. These are very tedious. They hurt your muscles because if you haven't used these in a long time, you're definitely gonna use them now. It's kind of like squishing a spring constantly over and over and over again. But once you're done, you're like, man, hopefully that was it. Trust me when I say this, these are so much easier to do. You will still need to trim some of these, because if you notice, they still protrude out the board from the other side, but they don't do it as much. So the good thing here is you can just solder these in place if you want to. So what we're going to do is, before we solder these completely onto the board permanently, we're going to actually solder the pins in place using this board. So what you're going to do now is you're going to move your pins aside, or your Arduinos aside right here. You're going to make sure that it's facing in this direction where the Arduino Pro Mini is showing. So you have Arduino Pro Mini node 2, node 4, 6, 8, and then 1, 3, 5, and 7. You want to make sure that when you put these boards in place that they are in the correct orientation. But what you're going to do now is you're going to take your pins and you're going to take them with the smaller side of what you just cut. So if the regular side that you didn't cut actually ends up being smaller, use that side instead. But now that you have these shorter sides, you're going to use those and you're going to put them face in. So they're not going to be on the Arduino side, they're going to be on the board side. So now I'm going to speed through this, but depending on how many nodes you actually want to put down, you will put these in going from 1 and up. So right now you should have your board loosely populated with all the pins. However, sometimes if the pins are too long, you can notice that they don't exactly sit flush. So you could have done this before, or you could do this right now. We suggest just putting a bunch of spacers to prop it up. And what we're going to use are actually the 5808s, and we're just going to put them underneath each corner. What this will allow it to do is get the pins at the right height so that everything can sit flush and not jiggle around as much. But also, so it'll prevent you from burning a hole through a mat if you aren't using a silicon mat. So now this is a little bit difficult, but we need to put the Arduinos in their spots. So again, remember, the single pin here, which says D9, needs to go to pin 9. So just gently put it on top, making sure that it sits flush. This is also a good time to use a pair of tweezers. You can also start from the middle and work your way out in case it doesn't necessarily fit. These can be a little bit tricky. There we go. This one right here. Sometimes you're lucky and they just fall right in. Put this one right here. Come on. You can do it. And again, remember, the buttons always go towards the inside of the board. That would have been disastrous. Sometimes the pins fall out, so you need to put them back without disturbing the other boards. So get yourself a nice good pair of tweezers. There we go. Just takes a little bit of finagling to get it all together. Okay, so now that you're at this point, you want to tack down certain pins. So what we suggest is to tack down the 9-pin and the raw pin, and those are the exact like diagonals of the boards. And then you'll just work your way through all of the pins that are necessary. Remember, you don't have to solder every single hole because there's not a pin in every hole. You're just going to solder the ones with pins going through them. So with your handy dandy iron at the right temperature and your solder, you're going to go through, you're going to solder each one. So at this point, I'm just going to speed through this, and when I start talking again, that's when we will move on to the next step. So now that you've tacked all of the pins to each of the boards, you can kind of move them out of the way if you want to. You can finish them up either in where they sit right now, or you can finish them up on the side if you want to. But the main important part is, now that you've got these tacked, make sure, and you should have done this before we started this whole thing right here, that each of these boards are flashed. This might be your last chance to actually do this. So what we need to do is we need to take these boards out, and we will need to solder some jumper wires or jumper pads. These pads serve two functions. The first function is for power, and that's what GP and the number is. So GP1 is the jumper pad for the power for node 1 Arduino power. And the reason why we put this here is if you wanted to do an FTDI flash while these boards are soldered in, you don't want to power the rest of the board. This actually will prevent the rest of the boards from powering if you use the FTDI adapter on the board. So we suggest you soldering every single one that you have a node for. So if you have 1 through 8, you need to solder JP1, JP2, JP3, JP4, JP5, 6, 7, and finally JP8. And the JPs are always on the opposite ends of the board. They're on the outside. These RST pads on the center, these are your reset pads. You do not have to solder them if you have an even number of nodes. The only reason you would ever solder one of these is if you had an odd number node. For example, if you had a 5-node configuration where you had 1, 2, 3, 4, and 5 nodes, making it an odd numbered node setting, you would need to solder RST5 only. And the reason is the odd node can't reset itself without someone resetting it for it. Now, the devs have and these are the RotorHazard devs. They have made it so that the last node is actually reset by the Raspberry Pi. These nodes, each pair, so node 1 and 2, will actually reset themselves. Node 2, when it's flashing node 1, will actually reset node 1. Likewise, it'll flip. When flashing node 2, node 1 will reset node 2. However, the odd number 1 doesn't have any 1 to reset it. So that's why you have to solder the last jumper pin of RST of the node that you're going to be using if you're using an odd numbered node pair. Sorry, odd numbered node, not pair. So right now, since we're doing an 8 node configuration, each node has a pair that it sits with. 1 is with 2, 3 is with 4, 5 is with 6, 7 is with 8. So we don't need to solder any of the jumper pads for the RST pads. I know it's a little confusing because we put in RST2, 4, 6, and 8. We just put those in there just in case, but really all you would need to focus on is 1, 3, 5, and 7. We would hope you wouldn't do all of this just for a 1 node pair or a 3 node pair. 5 node pair, that would be fine. I mean, it'd be pretty worth it. 7 definitely, but to keep things simple, we suggest you actually do pairs of nodes. So a 4 node configuration, a 6 node configuration, or even an 8 node. If you decided to do a 2 node configuration, we would suggest you actually wiring these out by hand. Just because this is sort of a lot of wasted space here. You can obviously make your configuration even smaller with a 2 node pair with a little bit of rewiring over here. You could flip this over on the top. Of course, you'd have to crisscross the wires, but you could create 2 nodes up on top of that and have a small little tiny stack if you wanted to. But for this, using the full 8, because you can always turn them off in the software. In RotorHazard, you can actually turn them off in the settings. We would just suggest you doing an even numbered node system. So I'm going to solder, while these are out, the power lines for each pair of, or for each node. So that's JP1, JP2, JP4, JP6, JP8, over here, this one is JP7, this one is JP5, and JP3. There is just enough room between each of these where you can actually get to it and desolder it. Remember beforehand I told you, like over here with the GPIO pins, you could desolder those and resolder it onto the other side. Well, in this case, you could do the same thing. You can use a fresh, clean soldering iron here and heat it up and then pull off as much solder as you can. The preferred method, though, is to use some braided copper wire to soak up the material, but there is just barely enough room to get your iron in here to do these pads. We pretty much guarantee that you probably will never have to do this, but on the off chance that you will, there is just enough room. So while we're here, we're going to put our Arduinos back onto the board, and if they offer up a little bit of resistance, just kind of wiggle them around until they fall back into place. And then what you're going to do from here is you're going to solder all of the points that are going to be needed, and then you're going to use tape. And what you're going to do is you're going to essentially just take this tape, you're going to cut a piece like so, you're going to lift up the board, you're going to finish the tape on the other side here and the other side here. And this is why we wanted you to take the tape. Once you flip it over, you can put it flush back on top right here, and now you can solder all of the points on this side. Remember, it's the ones that are only needed, which are essentially every single round hole on this side of the board. That's needed, that's needed, that's needed. All of these are needed. We will not touch these until later. But what we want to do, though, is the reason why I haven't started this, is we want to take the boards back off again. Why? Well, you notice how on this side of the board we have the solder pads for the RX 5808s. What you're going to need to do is you're going to have to take your round pins, cut up a set where it has 8 pins in a line. You're going to take the female pin and you're going to solder these on. Now, this is a little bit more difficult because, one, you want to be able to have these exactly perpendicular to the board. That's where a little bit of tape will help you in this. And two, you want to make sure that when you put these back on, let me show here, you can see here there's barely enough room for any margin of error. So these ones you don't have to trim. You can if you want, but we have not been doing that. We don't suggest it. But you will need to cut out a lot of these, one for every single RX 5808 you're going to use, basically one for every node that you're going to use. You're going to put them into place. You're going to use a little bit of tape to help you put them into line, flip it upside down, and then you're going to solder the back here. And you're going to solder every single one of these. Even though not every one of them are needed, they are needed to hold them into place. And basically, I've got one already prepared here. You can see that what they are is, it's these pins right here. We've cut off the tops of all of them flush with the boss right here, this larger portion here, and then we've soldered that. Sorry, it's the opposite. We've actually we've cut all of the thinner part up here, flush with the plastic bit, and we've soldered the RX 5808s on the castellated side onto the bossed brass piece right here. You need to have the female adapters soldered into the board first before you can do this. And we will use some double-sided foam tape or sponge or whatever will raise the height of these boards. And the double-sided tape is a lot better because it actually sticks it into place and holds it in the right spot. We will put it here and we will solder them directly to the board. Making sure not to make these permanently contact each other, because with the RotorHazard timing system, the thing that ends up being the most difficult to figure out are these 5808 receivers. They are made with a proprietary chip. The circuit diagrams are not readily available. Only very few suppliers have actually the ability to make these. The unfortunate part is a lot of time the quality isn't exactly 100%, and they all differ in terms of the RSSI output. Some actually have a wide band for greater accuracy. Some have a very small band, and those are the more difficult to tune in the software. And it's not RotorHazard that's to blame for that. It's the people that make the RX 5808 chips. There's many different versions, pretty much the same format, but different components on the inside, different resistance values, different tolerances on the resistance values. Some of these chips are made by cheaper suppliers, so unfortunately also if you buy a more expensive one, that doesn't necessarily mean that it's a quality version. So we are going to be using the commercially made ones for now. In the future, we hope to actually, and you can kind of see a little bit of a sneak peek here, we've been trying to reverse the traces on the board to make our own. There are chips that are readily available that are the modules on the inside, and then with some crystals and some other things that we can get from DigiKey, we will make our own tuned board, because as you can see here on these boards, not only can you get video and ground, you can also get some audio out of it as well. On a timing system, you don't need that. And you can also see here, there's a lot of wasted space, especially the blue component here. A lot of these components will actually go away, and you can reduce the footprint. So we hope to someday actually make versions of our own, but what we're going to do now is use the commercially made one. So again, the reason why we opt out of permanently installing them on the board, because even though you could actually put in some of these pins here and directly solder it into place and be done with it, and then you can desolder it afterwards, the problem is, if you can tell on my soldering iron, the heating element only goes so far. You would really want one that actually extends all the way over if you did the permanent method. So that's why we do it this way, so that way when you're testing your node or your whole system out in the field, you can actually take them out and you can replace them with others. So hopefully you didn't buy just 8. Hopefully you bought a little bit extra. We did mention that on the website, that you would want to probably buy maybe 10, maybe 12 of these nodes if you're doing an 8-node system, because not only are the quality a little bit of a hit and a miss, but when you're tuning these, sometimes you'll find that some of these are just not that great, but you happen to might have another one in your bucket of RXs that you can pull out and swap them out. So that way it's a lot better, and it's also easier maintained up on top. So the next steps, we're going to cut these out. We're going to put these on here. We're going to make sure that they are very much perpendicular to the board, meaning this face along the side is perpendicular to the face up on top. And we're going to solder these on, making sure that the female side is on the top. And when I mean the top, it's the one with the most lettering, the RotorHazard timing system logo, and then also our logo here in Sleeping Dog Tech. Make sure it's this way, and then after these are done, then you can come in and then permanently install your Arduinos. Finishing up the top here, making sure all of your pins that are necessary are all soldered to the board itself, and then you can flip it over and you can finish soldering all of these here. So Next, I will do a time lapse of all of that, and we will stop at a certain point. We will check our work, and then after that, we will do the RX 5808s, and then we will wire the 7 pins together. We will take the 3D prints, put them together. If you wanted to put optional heat sinks on here, now would be the time. And then afterwards, we will go over briefly on how to modify your case by also putting on some fans, making sure that you know which hole size to use. And then from there, you can decorate it, because like one of our cases that we've done, we've just sticker bombed it, putting as many stickers as we wanted to, whether they're from FPV systems or from just regular stickers. And then from there, you'll compile the software using RotorHazard on the Raspberry Pi itself. And then after that, it will have been configured, and then you will use the RotorHazard GitHub to learn how to use the software and tune your different components, testing them out in the field. We will just get you to the point where you install the software in these videos. We will go over briefly on how to do the software on the manual on the website, but most of that is taken care of by the other groups, mainly the RotorHazard group, and some other well-known developers have also have their websites up. So we don't want to overlap where we need to, but we will get you to that point.